When describing radio propagation, you typically will be utilising the term clutter, clutter classes, clutter class types. And that's what we're going to introduce. Now, before we dive into it, it's worth pointing out within radio systems, we also describe what's called geotypes. So the idea is when we start looking at the environment, we might say this environment is a dense urban environment, or it's effectively an urban environment or a suburban environment, or as we go out of the city we start talking about being in a rural environment. But we can also have open water or fields, for example, where we class that as an open environment. Or the final geotype typically is a forest. So these are geotypes, and with them comes lots of clutter types. Now, you could say that a clutter type could relate to one of those geotypes. And what we would need to do is we'd need to look at an area that we're planning, radio planning, and take some, say, satellite imagery of that area, and we'd need to find some clutter information. And this clutter map here, illustrated here, could relate to different specifics in a map. So it could relate to buildings and trees and roads, for example, in a dense urban environment or an urban environment. So the idea is within the radio planning software, typically you'll have clutter classes, and what you do is you assign these clutter classes effectively to a geotype, and a geotype might have multiple clutter classes. And the idea is as radio propagates through that particular square, so you can see there's a little bit of a grid here, as it goes across a particular colour, the idea is that radio will be attenuated, and depending on the clutter class, depends on how much attenuation there is. So the idea is we have lots of different clutter classes. Now, it's not a case of a one-to-one mapping. So as an example, I've picked out two geotypes, dense, urban and open, which I've just previously mentioned. And it's just to give you some examples of different clutter types that you might find under this umbrella geotype, dense, urban. So as an example, you can see I've got dense urban low, dense urban high, airport terminal, industry, commercial, and each of these clutter types could have different properties in terms of losses within the radio propagation tool. If I go to an open environment, you can see I've got inland water, wetlands, low vegetation, streets, primary roads, the tarmac at the airport, again, all classed as open, again, and that can have certain propagation characteristics with each of these clutter types. Now, it's all right saying the tarmac, but the key thing then would be the resolution of the clutter map. And typically, when you look at clutter map resolution, it's in meters. So, for example, it might be a 20 by 20 meter resolution, like this, or a 10 by 10, or a 5 by 5, or 2 by 2, or 1 by 1. And the idea is for that resolution, each of these colours represents a certain clutter type. So within this 20 by 20 meter square, you can say this is, for example, some buildings, or this is some foliage, or this is some airport tarmac. The idea being it's all based on a 20 by 20 meter resolution. However, you can get different resolution clutter maps. So you can have a 10 by 10 or a 2 by 2. And what I wanted to highlight is it's a combination here of the amount of intelligence you give the propagation modeling software by providing a higher resolution clutter data. And the idea is these two are actually of the same area, but if you took a little square, let's say we take this 20 by 20 meter square, and we look at it from a 10 by 10 meter resolution, you can see not all of those 10 by 10 meter squares are equal. However, when it comes to 20 by 20, we're saying, well, the majority in this case are light green. In the 10 by 10 meter, one of them is a darker green. So therefore, you can see there is a delta. Now, the key thing is you might say, well, just use a 10 by 10, just use a 2 by 2. It's cost. So usually with clutter models, there is an element of cost. How do you actually get it? So these clutter models come from things like doing for example, airplane taking photography, aerial photography from different angles, looking at sort of the 3D element of it, as well as using AI to work out classification. Is that road? Is that trees? Is that buildings, etc.? As well as doing surveys, as well as using things like LiDAR to do sort of surveys of particular areas. So you might find that you might have a certain resolution for a dense urban environment, but as you go out towards a rural environment, you might have very low resolution when it comes to the clutter data.